Hey everybody, this is Brad Dyke. How are you doing? I hope everything is doing well. Um, Today's topic is we're going to be talking about AI in your IT labs, your home labs. And we have done some videos on using like a HP DL Gen 9 380 platform as an example that we built natively to be able to handle AI intelligence effectively within a Proxmox cluster. So, do you need to have that kind of environment? No, not really. The truth of the matter is, if you just have a couple of thin thin PCs with, I would say, some i7 processors, 8 processor cores, equivalencies with 32 gigs of RAM. Build a few of those into a cluster state with Proxmox, and you can use Docker containerization to create your AI chat TP style approach for learning the basics of how do you bring in the libraries that support AI and understand that how you're processing is dictated by the type of processing you have available, i.e., CPUs versus GPUs and CPUs, and the combination effects. Now, we focused on building the hardware and changing the configurations for GPUs, though in my opinion, it's too soon. Um, it's a difficult process to bring GPUs into the equation, but do you need them for this? No, you don't. What you basically need is something very similar to something like this. It's a small form factor platform. Any of them will do as long as they've got an i7 8 core and can handle up to 64 gigs of RAM. And you have a few of them. I would say three, four, maybe. I would say probably would work really well. And then with that, you of course you install Proxmox on your boxes to make sure that you have that platform, and then you will deploy Docker, and you'll deploy a Docker image with the AI intelligence that you're looking for on. And these do not have sophisticated GPUs in them. They have hybrid CPU GPUs, which of course you really won't be able to take advantage of, at least that I have seen so far, with that. Now, on that topic, I will say that if you're sitting there trying to think this out, and this is what we're talking about now, this whole video is about the planning side. Um, you probably should stop before you buy anything. There are a couple of narratives out there that you should test each of them, and you can do it on your local PC with a small Docker engine. Um, to understand the configuration requirements that you need to do. You see that the requirements are driven both by your Proxmox environment and the availability of resources based on your processor, your RAM, and your resources. So depending on how old your equipment is or new, will dictate kind of the way you want to make sure you make those resources available. Now, with that being said, the other part of that is your ability to bring the libraries in. So my suggestion on that part is first make sure you understand and configure the Proxmox the correct way so that you're able to handle your workloads. The second thing is understand the AI engine which you're working with and understand the libraries you need. Now those are going to dictate some things that you want to have in the game. And at that point stage, the libraries are what are basically the repositories of intelligence that the correlational processes that AI does to come up with an answer. And you can get really, really colorful real quick if you're not careful. A lot of the times, the average library file is like 14 gigs, or could be pretty big. So understand that, so you can better plan out your resources and understand the growth patterns too. Once you've done that, then at that point stage, you know your hardware, you know the Proxmox configuration, and you've picked the AI you need for what you want to do. With those in place, then I would say go out, buy yourself some systems, go low dollar on the config systems themselves. Make sure the processor is all you're really buying. It probably has 8 gigs in it or something like that. And then, of course, then put in your resources in here to boost it up to, hopefully 32 gigs, 16 gigs minimum, and then start to bring together that Proxmox platform. So with that being the case, you'll be able to set yourself up in a pretty robust platform that you could back out very quickly and then readapt it out in such a way so that it's going to, what I would say, streamline your process as you get better at it. Now, you notice that I'm not going into the types of AI engines out there because I've only done two myself. One in relationship to software support strategies related to CI/CD and DevOps processing, and the initial 1, 2, 3 process for AI. Because when I started realizing how many options are out there, I realized, wow, that's not a rabbit hole I want to go down just yet, because of two reasons. And this is the other crucial detail I think it's valuable here for this short video. It's not done yet. If you've worked into environments where you've with, let's say, Microsoft Windows and Server, or Linux environments, and or operations environments, or enterprise environments, or topography environments, and so on, the first couple of renditions of it are pretty raw. And that's what I see here with AI and working with AI. Environments like VMware, Proxmox, and so on indirectly can be configured out, but they're not optimized. So that means I already know pretty much for a fact that down the road, these tools will come out with optimized configurations, and it will be literally just a simple value check change, not the complications you see today. So if you're going to do AI today, understand you've got a lot of extra steps to do, starting with Proxmox and then down into the actual environments themselves. We have the service, but we don't have good integration for the platforms that would support and host that service. And that integration is loosey-goosey right now. You're doing most of it. There is no autonomous optimizing going on in this equation. And don't confuse platform optimization with AI. They're unrelated. AI is a service to give you an answer to a question that you propose. Maybe mathematical, scientific, technology-based, or English-based, or another language. The key thing about AI is that it's a service. The processes of optimizing and efficiently handling that service, called AI, or any other service, is still in flux. So that means today, yeah, I won't kid you, it's about 55 steps. That's a lot. Just to be able to say, I want to be able to use these resources effectively for AI. Can you just deploy AI on a general Docker? Yeah, you can. But the very first thing you're going to be doing is you're going to be taking your watch out and you're going to be counting the seconds, because it's going to use only what it has. Now, it doesn't mean that what you have isn't effective. It just means you have to optimize the interfacing processes more effectively so that it knows those resources exist first. That's the biggie right there. And then secondly, then collectively work at using those resources efficiently. And that will drive to number 3, faster response time. So in the industry of AI, you hear us talk about the fact that, hey, it's going to take a lot of power to run AI. And it's going to take a lot of cooling. And it's going to take a lot of this, and a lot of that, and a lot of this, and a lot of that. That's rhetoric. Heard that back in the days of enterprise data centers. Heard that back in the days of cloud infrastructure. Heard that back in the days, everything's going to be expensive. That's true and not true. 90% of the services we put into operations get 1 to 7% usage. That's it. We never build hardware to run at 80 or 90%. Now, what we do is we will have 10 or 15 services, each pulling 4 or 5% each. That we will do. But the bottom line is, understand, us IT geeks like to talk big about the stuff the toys we play with, and we want everybody to pay attention to what we say this time, opposed to all the other times. And it's it's a little bit of rhetoric. But the truth of the matter is, can AI be expensive? Oh, absolutely, because it's new. That's it in a nutshell. It's not fully vetted. It's not fully tested. It's still in a development stage, technically speaking. So yes, it will be expensive. It has nothing to do with what you're buying. It has to do with the fact it's new. Really, that's very seriously true. The other part of that aspect is that the driving force for profitability means that they're always going to make it cheap. It's just like, you know, a $2 pair of shoes is being sold for $125. See what I mean? So they understand, i.e., the Microsoft, the Azures, and all of the IT industry companies that are involved. They understand the expense of what they're doing, but they're also promise you they're going to drive down those costs as hard and as fast as they can, so that they get the profit they want to see. And that's the last part about this. You know, our IT labs are built out of little boxes. All right, things we recycle. We are the optimists of profitability, but our profitability is in learning, not in cash. The same exists for the industries that you work for, and you do have to respect it to a point, but then it gets a little bit too much. Then you have to take a step back, and that's why technology eventually fades out, because of that very genre. The hype is the hype is the hype is the hype. When the hype's over and you really can't sell it, let's go sell the next hype, because that's what keeps us in business. So AI is kind of inside that loop a little bit right now still. It's going to get mainstreamed, just like VM environments and hypervisors and all that became mainstream and so on. Then we're going to see the profitability. Then we're going to see the automated optimization effects and so much more. So keep your hats on. There's a lot more coming. And yeah, it should still work just fine on your microclusters. Well, this is Brad Dyke signing off for doing a short video. I'm going to be doing a video about something that's very true about this industry next. It's an eye-opener, but also it's not. You guys take care. God bless, and have a great week.